Welcome back to the deep dive. We have a stack of research today that honestly feels a bit like reading a cyberpunk novel from the 90s,
Right.
except it's actually happening.
Yep.
Right now, in 2026,
Yeah.
we are tackling a dream that I think pretty much everyone has had since science fiction first promised it to us.
Oh, yeah.
I'm talking about the personal AI assistant. You know the drill, a digital sidekick that manages your emails, organizes your calendar.
Maybe books your flights while you sleep.
Exactly.
It's the ultimate convenience. But, usually that convenience comes with a pretty steep price tag.
And you don't mean money.
No, not at all. I mean your data. You're essentially handing over the keys to your entire digital life to some mega corporation and just hoping they don't lose them.
Right. And you have to trade your privacy for that magic. But what if you didn't? What if I told you there's a way to have that assistant one that runs on your own hardware, doesn't sell your secrets, and
When it's branded with a lobster.
and is branded with a lobster?
Or a prawn. I think the community forums are still debating that one.
We were talking about OpenClaw, which it's basically become the open source hit of 2026. It's everywhere. And its philosophy is literally described as the way of the prawn.
It is quirky branding, for sure. But underneath that shell, pun intended, is a really serious piece of technology.
So it's more than just a funny logo.
Oh, absolutely. It's a response to the whole black box nature of big tech AI.
Okay, so here is our mission for this deep dive. We aren't just going to talk about what OpenClaw is. We're going to try to turn you, the listener, into a tech hero.
I like that.
We're going to explain how to install this thing, but we're going to do it the right way. Because, as you pointed out to me before we started, plugging an AI directly into your life can be risky.
It's a massive risk. I mean, think about it. You're giving an autonomous agent access to your inbox, your boss's contact info, maybe your banking alerts.
Everything.
If that assistant gets hacked or if it picks up some malware and it's running directly on your main computer, well, it's game over.
Which brings us to the core of today's discussion. The virtual machine. The VM.
The safety net.
Precisely. So, buckle up. We're going to walk through how to install OpenClaw inside a virtual machine, balancing that innovation with, actual privacy.
Let's do it.
Let's unpack this. First off, what exactly is OpenClaw? Is it just another chatbot?
No, and that's a really common misconception. It's better to think of OpenClaw as a bridge.
A bridge?
Yeah, it's not the brain itself, it's the connector. It connects those powerful AI models like Anthropic's Claude, OpenAI's GPT, Google's Gemini to your everyday apps.
Like Telegram and WhatsApp.
Exactly. So it sits in the middle, it takes the message from your phone, translates it for the AI, gets the answer, and then sends it back to you.
And here's the key part, right? The part that's driving its popularity.
This is the differentiator. The
Well-
bridge runs on your local machine. You aren't logging into a cloud platform where every single interaction is stored on someone else's server. You control the bridge.
And you can even swap out the AI models.
Totally. You can swap out those big corporate models for local ones, like a llama, if you want, total complete privacy.
So wait, if I use a local model, literally nothing leaves my house.
Exactly. Unlike the big tech assistants that arguably farm your data to train their next model, OpenClaw, or our little lobstercito, it keeps it all to itself.
Lobstercito! I love that. Okay, so we have this private, powerful assistant. But you mentioned the caution. Why can't I just install it directly on my Windows desktop and call it a day? Why this whole virtual machine rigmarole?
You could install it directly, but you really, really shouldn't.
Yep.
This brings us to the whole security logic of it.
Right.
The source material uses a really great analogy here. The beach sandbox.
Oh, I liked this one. Basically, imagine a sandbox at the beach. You can build castles, you can smash them down, throw sand everywhere, make a total mess.
Right.
But because it's a sandbox, that mess doesn't get into your living room.
That's the perfect visual. And in technical terms, that sandbox is the virtual machine. It's an isolated computer running inside your real computer.
A computer in a computer.
Yep. So if OpenClaw accidentally downloads a virus, or if a hacker somehow compromises the AI, the damage is contained within that bubble. It doesn't touch your family photos, your tax returns.
It's their main operating system.
Exactly. It can't get out.
Is this just, being paranoid? Or is there real data backing this up? Because it sounds like a lot of work if the risk is minimal.
It is definitely not just paranoia. If we look at the numbers, groups like OWASP and NIST, the National Institute of Standards and Technology, have reported that 70% of AI breaches,
70.
70,
Right.
70% of AI breaches come from non-isolated exposures.
Wow. That's huge.
It's a massive majority. And experts from places like MIT, open source documentation, they consistently warn about this. When you're dealing with experimental software, and let's be honest, autonomous AI agents are still experimental. Isolation is your best friend.
You don't want a glitch to have access to your whole hard drive.
You really don't.
Okay, you've convinced me. I want the sandbox. I want to build the castle without getting sand in the carpet. What do I need to get started? What's the shopping list?
Fortunately, the barrier to entry is pretty low. Software-wise, you just need virtualization software.
Like what?
VirtualBox is the standard recommendation. It's free, it's open source. If you're in a corporate setup, you might use VMware. If you're a pro, you're probably already using something like Proxmox.
And for the operating system inside that sandbox?
The sources heavily recommend Ubuntu 22.04 LTS. It's stable, reliable, and it plays very nicely with all these AI tools.
What about hardware? Do I need some kind of supercomputer to run this lobster?
Not a supercomputer, but it does need some juice. To keep OpenClaw moving fluently, you'll want to assign that virtual machine at least 4 gigs of RAM and 2 CPU cores.
That seems manageable for most modern laptops.
For sure.
Now, here's where it gets really interesting for all the Windows users out there. The source material suggests that pure Windows isn't ideal for this. Why is that?
It's really about the architecture. Most of these open source AI tools are just native to Linux. Trying to force them onto standard Windows can be like trying to fit a square peg in a round hole.
It'll work, but it's clumsy.
Exactly. It's friction heavy.
Oh.
So the recommendation is to use WSL2, the Windows subsystem for Linux, or ideally just run a full Linux VM like we're describing.
It's a chance to learn something new, right? I feel like Linux has this reputation for being, impossible for normal people.
Absolutely, but that's really changing. The source frames it beautifully. Treat it like solving a fun puzzle. You're learning basic Linux, which is a superpower in itself. It gives you a level of control that Windows just doesn't offer.
Okay, let's get to the meat of this, the step-by-step. We've got our virtual machine spinning, we've got Ubuntu running. How do we summon the prawn?
Step 1 is dependencies. OpenClaw is built on Node.js. You need version 22 or higher.
Okay, and for those listening who might be a little intimidated by the command line, let's walk through this. You're going to type a command that starts with curl. What does curl actually do? It sounds like a gym exercise.
It does. Think of curl like a digital golden retriever. You give it a URL, you say go fetch, and it runs out to the internet, grabs the file you asked for, and brings it right back.
Okay, so it fetches the script, and then you run sudo apt install.
Right.
Sudo. That is the magic word in Linux, isn't it?
It stands for a super user do. It's basically you telling the computer, I am the boss, do exactly what I say. It grants administrator privileges.
Got it.
But let me interject with a crucial security tip here. You'll notice sudo is used for installing, but when you're actually running the application later, you should never, ever do it as the root user.
Wait, why is that? If I'm the boss, shouldn't I run everything as the boss?
No, because of what NIST calls the principle of least privilege.
Huh?
Think about it this way. If you run the AI as the root, the super admin, and that AI gets hijacked.
The hijacker becomes the super admin.
Yeah, exactly. They have the keys to the entire castle. But if you run it as a standard user and it gets hijacked, the damage they can do is limited to just that user's files.
Smart. Limit the blast radius. Okay, so Node is installed. Now for the star of the show.
To install OpenClaw, the command is delightfully simple. npm install -g OpenClaw at latest.
And NPM is just like the App Store for code.
Pretty much. It's the package manager that pulls the latest version of the lobster directly from the repository.
Once that's done, we have to set it up. The source mentions a wizard.
Right. You run OpenClaw onboard install daemon. This is the setup process. It configures a background service, the daemon, that keeps the AI awake and listening for your commands.
A daemon. Another one of those tech words that sounds sinister but really isn't.
It just means a process that runs in the background. It waits silently until you need it.
And then we open the gates. The final command to start the whole system is OpenClaw gateway port 18789.
And just like that, the bridge is open.
I have to share this joke from the source material because it cracked me up. What does an AI lobster say to a hacker?
I'm waiting. Let's claw off my data.
It's terrible, but I like it. It captures the spirit of the project perfectly.
It is absolute dad joke territory, but it works. Okay, so it's installed. But we aren't done. We need to make sure it's healthy and secure. The source mentions a doctor.
Yes, the command OpenClaw Doctor. This is a built-in diagnostic tool. It runs a check for risks, verifies your security policies, and tells you if you've left any digital doors unlocked.
And one of those locks is the secure pairing feature. This seems vital if you're connecting this to something public like Telegram.
Absolutely. You don't want just anyone messaging your bot and asking it to read your emails. Secure pairing means that for any direct messages, you have to approve the connection with a specific code.
It blocks strangers by default.
Exactly. Speaking of Telegram, how do we actually get the lobster talking on our phone?
You use something called a bot father token. Essentially, you tell Telegram, I'm making a bot. It gives you a secret key, a long string of characters, and you plug that key into OpenClaw. That establishes the secure tunnel between your chat app and your home server.
Okay. Now, for the listeners who really want to fortify this thing, I'm talking Fort Knox levels of security. What else can we do? The source material suggests we can go even deeper.
If you want to go deeper, you look at defense in depth. And the first advanced recommendation is Docker.
Wait, we already have a VM. Why would we need Docker, too? Isn't that redundant?
Not quite. Think of the VM as your house. You lock the front door.
Okay.
Docker is like a safe inside the house. If someone breaks into the house, the VM, they still have to crack the safe, the Docker container, to get to the really sensitive application data.
Ah, so you're double bagging it.
Exactly. Running OpenClaw inside a Docker container within your VM provides another whole layer of sandboxing. And studies show this can reduce exploits by up to 85%. It creates a tiny, controlled environment where the app can only see exactly what it needs to see and nothing more.
That makes a lot of sense. What about network security? If I want to talk to my prawn while I'm at a coffee shop, don't I have to open my home network to the internet? That sounds really risky.
It is risky if you do something called port forwarding on your router. That's like leaving your front door wide open. The pro move here is to use a mesh VPN, like Tailscale or WireGuard.
How does that change the equation?
With a mesh VPN installed inside the VM, your phone and your VM basically think they are on the same Wi-Fi network, even if you're on the other side of the world.
So it's a private tunnel.
Right. The traffic is encrypted, and it's invisible to the public internet. You don't have to open any ports. It is infinitely safer. That way, your assistant isn't just sitting there waiting to be poked.
Okay, now, we have to be real with our listeners. We call this a deep dive because we look at the whole picture, warts and all. What are the downsides here? What makes this difficult?
Well, the first reality check is resource intensity. AI models are hungry. They eat CPU and GPU for breakfast.
So if I'm running this on an old laptop, it might struggle.
It might, yeah. If you try to run a massive model locally, your fans are going to sound like a jet engine, and you might be waiting 30 seconds for a reply.
What's the solution there?
The solution is to use lighter local models via Ollama. They are specifically optimized for consumer hardware.
What about the complexity? I mean, we threw around terms like daemon, Docker, and sudo. That's a lot for someone who just wants a better calendar app.
And that is the hurdle. The source notes that about 40% of novice users skip the Docker configuration because it's hard.
But skipping it increases the risk.
Massively. It's a trade-off. You are trading convenience for control, and that requires a learning curve. You have to be willing to learn the vocabulary.
And bugs. I mean, this is new software.
It's software from 2026. It's young. Of course there will be glitches.
The source had a great take on this. It's not a bug, it's a feature, like burnt coffee that wakes you up more.
A very generous interpretation, but yes, you have to be patient. And regular maintenance is key. You need to run NPM update frequently to patch those bugs, and you actually need to look at your logs.
So it's like a pet. You have to feed it updates and clean up after it.
That's the responsibility ownership. When you use a corporate AI, they do the maintenance. When you use OpenClaw, you're the mechanic.
So let's bring it all home. What does this all mean for the listener? Why should they go through all this trouble?
It means that you have an option. You don't have to accept the default setting of big tech creates, I consume. Installing OpenClaw in a VM gives you superpowers. It gives you an assistant that works for you on your terms.
And the formula the source gave us.
Isolation plus strict policies equals peace of mind.
I love that. And honestly, even if you try this installation and you fail, even if you get stuck on step 3, you've learned about virtualization. You've learned about the command line. That in itself is a win.
It is. But before we go, I want to leave the listener with one last provocative thought that came from the source material. It's about the legal reality of all this.
Lay it on us.
We're building private, unsupervised AI assistants. If your assistant running on your hardware under your control does something wrong, maybe it sends a harassing email to a colleague or interacts with a system it shouldn't, who's responsible?
Whoa. There's no corporate terms of service to hide behind. You can't blame Google or Microsoft.
Exactly. You are the admin. You are the owner. It requires constant supervision aligned with ethical guides like those from the IE. If your digital dog bites the mailman,
You're the one paying the bill.
you're the one paying the bill.
That is a heavy thought to chew on. You really are the captain of your own ship now.
Right?
Well, on that note, we want you to go out there, download VirtualBox, and try to tame the lobster.
Let us know how it goes.
Until next time, happy coding. Thanks for listening to The Deep Dive.